I'm going to be presenting today on the topic of how to migrate tables in Apache Iceberg. Okay, as you can see here at Dremio, I wear many hats, being moderator and the speaker right now. But basically, what I'm going to be talking about today is basically, again, how to migrate your tables to Apache Iceberg. Okay, and again, who am I? My name is Alex Merced. I'm a developer advocate at Dremio. I like to do a lot of things, such as creating a lot of content around things like Apache Iceberg, Apache Arrow, the data lakehouse in general. You've seen in our weekly broadcast, not only data waves, which if you haven't subscribed on iTunes or Spotify, you should. Okay, and also as you hear, I'm one of the authors of that upcoming book, Apache Iceberg: The Definitive Guide. So look forward to that. But again, today we're going to be talking about several things, like basically migrating to Apache Iceberg. Not just the how, but the why. And also like, where are we coming from? So like basically, yes, we want to go to Apache Iceberg, but why and where are we coming from? And we're going to have that discussion today. So we'll discuss sort of what the old standard was, which was Apache Hive. We're talking about what the problems with that old standard were, and why do we want to migrate to Iceberg, and then how to do it. Okay, and then basically when we talk about how to do it, we'll talk about how to do it from anywhere, not just from Apache Hive, but if you have Delta Lake tables you want to turn to Iceberg, you have Hoodie tables you want to turn into Apache Iceberg, you will learn how by the end of this presentation. Okay, so first let's just discuss sort of where we were before. Okay, so before sort of the modern era of the data lakehouse, you had data lakes and you had this need to interact with your data on the data lake as sort of individual tables. So you may have a data set that's 1,000 Parquet files, 1,000 ORC files, and you didn't want to have to sit there and say, these files are the data set every single time you wanted to run a query. So what would you do? You needed a table format, and that's where Hive came in. It basically, they came up with a way to be able to sit there and say, these 1,000 files, these 10,000 files, whatever number of files, that they're one singular data set. And that was the Apache Hive format, okay? But basically the way they did it though is they did it by taking a directory and saying, hey, all the files in this directory, well, that's a table. And that worked out really well. You could sit there and say, okay, I want to query this table, and it knows that all the files in this folder are a table. But this did come with several problems, okay, and pros. So pros is that this was the best approach they had at the time, and it became the de facto standard, okay? You see Apache Hive tables everywhere, okay? It did enable things, being able to do certain practices like partitioning on the data lake, which was nice, and it was file format agnostic, and you could atomically update whole partitions. These were all good things, and it did give us consistency. It gave us one answer to the question of what is the table? But when it came to more granular changes, like you wanted to update a row, well, you'd have to kind of update the whole partition. Okay, so smaller updates were inefficient, concurrent updates were really difficult. Having to list all these directories and subdirectories for partitioning would really kind of slow down queries. So there was all these imperfections with that way. So basically, we flash forward to today, we've moved to the sort of era of the modern data format. Okay, so you've heard of like Apache Iceberg, Apache Hoodie, Delta Lake, and at a high level, they kind of all give you the main benefit, the ability to, one, recognize the table on your data lake. They're going to give you ACID transactions, so that way you can transact atomically on your data lake, and they're going to give you the ability to do time travel, okay? But there are reasons, okay, you might specifically want to migrate to Apache Iceberg, okay? And again, what Apache Iceberg does differently is that it really breaks away from that directory format. It doesn't matter where your files are. With Apache Iceberg, what your table is defined by a tree of metadata, which has 3 layers. So you have the top layer, which defines the table. Those are the metadata files. You have the middle layer, the snapshot files or manifest lists that define individual snapshots of the table. And then every snapshot is made up of many manifests, which are groups of files that make up the table at that point in time. Each of these layers with metadata that allow engines to query that data more efficiently and faster. So that's kind of how it achieves its performance. And because the manifests can list exactly where the file is, it doesn't matter if they're all in the same folder. Okay, and that provides huge benefits. Okay, and we'll talk about some of those very unique to Apache Iceberg benefits now, okay? So this enables certain features that cannot be enabled anywhere else that rely more on that directory structure, such as partition evolution. Because we don't care about what folder the files are in for them to be partitioned, because all the partitioning data is actually tracked in the metadata. It just says, okay, hey, this column, applying this transform, that's how this table is partitioned. It doesn't matter what the folders they're in, you can actually have partition evolution, meaning you can actually change the way the table is being partitioned anytime you want. So you might have a data that was partitioned by year, and then now you want to partition it by month. You can go change that, and all data going forward is partitioned by month without having to rewrite the old data, which was partitioned by year. So you don't have to rewrite petabytes of data just because you decided, hey, my partitioning needs have changed. That's pretty awesome, okay? And that's enabled because, again, the metadata does the work, not the physical structure or the physical location of the files. Compatibility mode. Okay, basically, one of the issues when you have your data on object storage like S3 is you might have throttling when too many requests to files under the same prefix or folder happens. Okay, and that can cause, well, slowdown, okay, because you're getting throttled requests. Well, you avoid that with Apache Iceberg because it has a compatibility mode that instead of distributing your files over folders for each partition, it creates a bunch of hashed folders. So the files for individual partition might be stretched across 10s, 20, 30 folders or prefixes, which reduce that potential throttling. So you don't have that issue. You have hidden partitioning, okay? Because the metadata is what tracks the partitioning, and the metadata can track a sort of function or transform that transforms the column data, you don't necessarily have to create an additional field. So in the past, what you'd have to do is if you wanted to partition the data by day, you would have to create an additional field beyond your timestamp columns, and then you would have to actually include those columns in your queries. And if you're the end consumer and you don't know that the table is architected in this way, you could accidentally do a full table scan, and that'd be a much slower query. So you have these features that are unique to Apache Iceberg. But not only are the features reasons to migrate, but there's also the tooling. Okay, Apache Iceberg has really been embraced by a lot of tools. So you have the ability to read Apache Iceberg tables, the ability to write Apache Iceberg tables from a lot of different tools. Okay, pretty much name the tool. It pretty much supports Iceberg at some level today, and that's only growing. Okay, so you have that wide ecosystem of tools you can use Apache Iceberg. And as you saw in today's keynote, the whole idea of data is code. Okay, you have the Dremio Arctic catalog, which is powered by that open source Project Nessie technology that's going to allow you to do branching and merging and all this kind of isolation and version control with your Iceberg tables. And again, that's versioning the Iceberg catalog. Okay, so this gives you a whole other level of benefit that you don't necessarily get right now at the catalog level with the other formats. And then there's just the openness of the project itself. So again, the Apache Iceberg project is super transparent. They have meetings every other week that anyone can join. So you can, if you want to know what's the direction of the project, what features they're developing, you can just sit on those meetings, read the notes, the actual notes from those meetings or minutes are there in a document that's easily accessible. There's a Slack channel where you can actually see the discussions on development, see discussions about helping people implement Apache Iceberg. Everything is very, very visible. Okay, and you have a wide variety. There's no particular company that kind of controls a project. There's Apple, Netflix, Tabular, Dremio, all contributing to the project to everyone's benefit. Okay, it's a real community project. So basically, you have the features, you have the tooling, you have the openness. These are all reasons why, in particular, you would want to migrate to Apache Iceberg. So now that we know what Apache Iceberg is and why we'd want to migrate to Apache Iceberg, let's talk about how. Okay. So the first step in your migration journey is choosing an Iceberg catalog, because essentially any tool that you're going to use to access your Iceberg tables, generally its first stop is whatever your catalog is. It's going to go to your catalog and say, hey, where is this particular table located? And each catalog has its different pros and cons. So let's talk about those pros and cons. So there's Project Nessie. Again, that's the open source Project Nessie. That's the thing that actually powers Dremio Arctic's data as code features. So like the whole branching, merging. Okay, so some pros to using a Project Nessie as your Iceberg catalog is, one, you get that Git-like functionality. So you have the ability to do branching, to do merging, which enables all sorts of cool things like multi-table transactions, the ability to roll back your entire catalog instead of having to roll back each table individually. Okay, and the cool thing about it, it's really easy to adopt. You can just go on Dremio's cloud platform and a couple of clicks and you have an Arctic catalog, okay? Like literally it's just a couple of clicks and you have a catalog. You can connect via Spark, it can connect via Flink, it can connect via Dremio, you can connect via Presto, and hopefully soon Trino. There's a pull request that's pending there onto the Trino project. So you can use all your favorite tools to access your Iceberg catalog and get those Git-like features. And you have a cloud managed service making it really easy to deploy. The only con, okay, is if you're not using Dremio Arctic, then you would have to stand up your own Project Nessie server, but that's also an option, okay? Basically, it's an open source project. You can stand up your own server and get those features. Another option is Hive Metastore. Now, Hive Metastore makes a lot of sense if you already use Hive Metastore. So in that case, you don't have to stand up another service. You don't have to worry about another service. You can just use your existing Hive Metastore as your catalog for your Iceberg tables. The con is, if you don't have Hive Metastore, then you'd actually have to set it up, which in that case, you might as well then just use Project Nessie if you're going to stand up a server. Okay, but it is an option. Okay, then there's AWS Glue. Okay, AWS Glue is basically a catalog built into AWS services. And the awesome thing about using AWS Glue as a catalog is that it really interrupts very well with all of AWS's other services. So if you are using Athena, if you're using Redshift, you're using all these other AWS tools, then AWS Glue makes a lot of sense as your Iceberg catalog. But if you're not using a lot of AWS tools, then maybe not. Then maybe one of the other options are a better choice. Okay, there are several other options, such as JDBC, where you can use any database as your catalog, HDFS, DynamoDB, and the new REST catalog. The only issue always is engine compatibility. Just because a different tool supports Iceberg, it doesn't necessarily mean they support connecting via the catalog that you use. So generally, you want to choose one of those more supported catalogs, so that way you make sure that as many tools are available to you as possible. Every day, more tools support more catalogs. So eventually, we'll hit a point where generally most tools will support most catalogs, and this becomes becomes more of an afterthought. But it is something. It's like the first major decision you need to make in that migration journey. Okay, because again, it will determine which tools you can use. Okay. Now, once you've decided on what your catalog is going to be, then the matter is just to start moving all your data to tables in that catalog. Okay, how do I do that? Well, there's generally two strategies to doing this. You can either do an in-place migration, which just means take all those files you already have, all those Parquet files you already have, and just reuse them. No need to write new ones, just add them to an Iceberg table, which is great because there's a lot less work involved. You don't have to rewrite any data. And that's, again, the beauty of Iceberg, because Iceberg doesn't depend on the file location. You can actually just point to files that are already somewhere else as part of your table without actually having to rewrite them into a different folder, which is really nice. Now, the other option is shadow migration, where you do rewrite all those tables, which, you know, is a fine option. But, you know, again, it's going to cost more because if you're rewriting petabytes of data, that's a lot of compute. But there are some benefits. So we'll talk about these different options and the different ways you can go about these options. Okay, now in an in-place migration, again, you're reusing the files you already have. We're going to kind of assume that all your data is in Parquet files. Okay, so if you, let's say you have a Hive table. So first scenario, you have a Hive table and you want to migrate that. That's already built into the Iceberg libraries. There's a command or a procedure called migrate. And what you can do is just say, hey, I have this Hive table right here. And then it will just turn that Hive table into an Iceberg table in your catalog. It will not rewrite any of the files. It'll just write new metadata across the files you already have. So you avoid all the rewriting of data. Super easy. The only downside, or the only thing to be careful of, is that when you run the migrate command, it does destroy the Hive table. So like the Hive table won't be accessible anymore. So generally you want to test it out first. The way you test it out is you use the snapshot procedure. And these are all Spark procedures. So the assumption here is this is part of the Iceberg Spark libraries, okay? As Dremio announced this morning, there are different new features on Dremio that allow you to do similar things like copy into and vacuum for different types of maintenance, but these are specifically Spark procedures in the Spark libraries for Iceberg, okay? So migrate, again, will turn that Hive table into an Iceberg table, but before you do that, you wanna use the snapshot command. That'll create a read-only version without destroying the Hive table. So that way you can see if the output is right. Like, hey, it's like, this is actually what I expected. And then if it all looks good, then you go back and run the migrate command. Okay, that way you can test it out before you make that leap. Okay, you don't accidentally destroy your Hive table accidentally and realize, oh, this didn't work out the way I expected. That would be bad. Okay, so that would be the way for a Hive table. So that's pretty straightforward. But what if it's not a Hive table? Okay, what if I have a whole bunch of Parquet files that are not using any table format? What if I'm using Hoodie? What if I'm using Delta Lake? Well, you have what's called the add files procedure. Now, what the add files procedure does, it just takes whatever files you point to and then writes metadata to include them in your table. So it doesn't matter where the file is located, doesn't matter what table format that it might have been associated with before, as long as your Iceberg table has a matching schema. So first you would create an empty Iceberg table with the matching schema, and then you can just run this procedure and say, hey, this folder of Parquet files, add that to this table. And now, going forward, those files are part of the table. The metadata is written, no data files are rewritten. The only thing to keep in mind is that if you're talking about a Delta Lake or a Hoodie table, then what you'd probably want to do is make sure that you only have the current snapshot in the folder. So you'd probably expire all previous snapshots and then run an operation to clean up all the other Parquet files. So that way the only Parquet files are the current snapshot. For when you add it, you have the current state of the table. Although that's going to get a lot easier. Because right now, just recently, they merged this, okay? So they just merged this Delta Lake module into the Iceberg code base. So going forward, there's actually a built-in way to sit there and say, hey, this Delta Lake table, make it an Iceberg table, okay? So this should probably show up probably in the next Iceberg release, since it's been merged into the repository. And essentially right now, you just have this function that you can see here at the bottom. You just pass it the Spark session, you pass it the identifier of the your new Iceberg table, and then you pass it the location of your Delta Lake table, and then it just, there it is. It just takes the current snapshot and makes it your Iceberg table, okay? And then I think they're gonna continue adding to it so that way eventually you can capture the whole history as well. But right now it'll just take that new snapshot and turn it into an Iceberg table. But, and even cooler, guess what? They're also doing the same thing for Hoodie, the exact same API, so it's gonna take the exact same arguments, okay? But this one is currently a work in progress. But eventually, again, that will just be baked into the Iceberg libraries. So being able to take your data from a Hive table, a Hoodie table, a Delta Lake table, you'll be able to just run a function and move it over, okay? So that's gonna get easier, okay, very, very soon. Okay, so that's how you would have done an in-place migration. Again, taking the existing files and moving them over. But how would I do a shadow migration where I just rewrite the data? Now, why would I want to do a shadow migration if I don't have to rewrite all the files? Well, maybe the files you have now aren't the files you want. Maybe the schema is not exactly what you wanted. Maybe you would rather resort and recluster the data so that it's more performant when you have this new table. So if you have to rewrite the data or you choose to rewrite the data, you might as well do all that. Change the partitioning, change the schema, make it exactly what you would want. And that's the nice thing about shadow migration. Since you're rewriting the data, you can make those kind of changes. This would typically be done through a CTAS statement or a create table as statement. So you would just do a create table as statement like the one I have here. So in here, what I'm doing is I'm basically changing the partitioning. So since I'm rewriting the table, okay, I'm going to decide the partition it using a bucket, a 16-part bucket, partition it by days in the timestamp column. I'm going to truncate the partition it by the last name column as well, based on the first two digits or first two digits. Okay, I can do that. Okay, because I'm rewriting the data anyways, I can take advantage of that. So that's one nice thing about a shadow migration. But the catch is you are rewriting all the data. Okay, so now that we've seen the two options, so again, you can either keep all the data you have and do an in-place migration. And again, you have all those different options for how to pull that off. Or you can do a shadow migration, rewrite the data through a CTAS statement. But in general, I now need to design the actual steps of doing that. Okay, so I see how to do the actual movement, but I need to create like a strategy of how I'm going to phase in from old table to new table. So let's talk a little bit about that. First, we'll just kind of reiterate sort of the different options you have. Okay, first you have the migrate option. That's going to be best if you have a Hive table. Okay, because that's currently designed for Hive tables. So basically, if you have a Hive table, it'll just move it right over. Right now, if you have anything else, add files is going to be your best option for an in-place migration. You just take the Parquet files, regardless of whether it's no table format at all or in another table format, you can just take those Parquet files and add them manually to your Iceberg table. CTAS, if you're doing a shadow migration. Okay, and again, the benefit of in-place, again, is you don't have to rewrite data files, but again, you can't change the schema or anything like that when you use the same data files. CTAS benefit is you can change your schema, you can change your partitioning, but you are rewriting your data files. So again, you have that cost of doing that. And one other thing I want to point out is that migration is not just about migrating from now to Iceberg, but again, as Iceberg catalogs proliferate, there's also going to be the issue of what if I want to switch catalogs? Because right now, it might make sense for you to use Hive because you have an existing Hive metastore. But you see things like Dremio Arctic, Project Nessie, and you're like, eventually I would like to use that. I want those data as code features. Okay, how would I do that later? Well, there's this register table operation that's built into the class catalog or the catalog class in the Java API. And basically what it does is you just say, hey, I have this catalog. So I would just create an instance of my Project Nessie catalog and say, hey, I have this table in my Hive. Here's the location of the metadata file. And it would just basically write it as a new table in there. No files get rewritten. It just takes that same table and just literally registers it with that other catalog. And you can now just use it with that other catalog as you would use it had you created it in that catalog in the first place. Okay, and they make that even easier. Instead of you having to write like a Java, always, every time I want to say like you write a script in the Java programming language, it's hard because when you say JavaScript, it kind of implies something else. So you would write a script in Java, Okay, instead of doing that, in the future, you'll be able to use a CLI tool. It's actually being written by someone at Dremio, and you'll be able to actually do all that from a CLI tool to actually move your data from one catalog to another catalog, to move it from Hive to Project Nessie, or from Hive to Glue, or however you want, or even to Hive, whatever you want to do. Okay, so basically, this whole catalog issue becomes less and less of an issue as all these technologies, and we'll come back to questions in just a moment. Okay, and our last piece here is basically you're going to want to kind of schedule this in like phases. So essentially, you want to start out this whole migration process. First, you want to basically read from your old table, okay, because you know your old table is still working. You want to still write to your old table, and then we begin the migration process. The first step is to create that new table and begin every time new data comes in, write to the old and new table, because you still want the new, old table until you know you can move off of it. So in phase two, all your readers should still be reading the old table, the Hive table, the Delta Lake table, the Hoodie table, but all your writes should be writing to both the old table and the Iceberg table. Once you're pretty comfortable that they're in sync, and basically the writers have kind of kept these things in sync, what you would then do is you would move into phase three. And now you would switch over all your readers to only read to the Iceberg table, but you'd still write to both tables just in case. So if there's any issues that come up, you still have that backup, that table, your old table just in case. And once you're 100% sure now everything's running smoothly and you can support it and all good, then you can pull the plug on that old table and move on and basically save all that storage and basically get rid of all the stuff you don't need anymore. Okay, so generally you want to kind of think of those phases and think about how you're going to execute each of those phases. So again, to kind of recap, first thing you want to do is like, first you have to decide, I want to migrate to Iceberg. Two, then you need to decide what catalog we're going to use. Once you decide what catalog you're going to use, you can decide how you're going to add your tables to that catalog, either in place or shadow. And then you put together your step-by-step plan to actually go through these phases. So that's sort of like the journey and the thought process of migrating to Iceberg. And with that, thanks. Now it's going to be time for questions. Again, my name is Alex Merced. That's my email. So again, if I can't get to every question today, just make sure to email me. And also follow me on Twitter at @AMDataLakehouse.